Today we are continuing looking at fractions on a number line. I can 100% guarantee there will be fractions on a number line on your test on Friday. And it is very, very likely you will see them on the EOG, so we're going to spend a little bit more time working with them. Today we've got a little bit of a longer title. It says fractions that are larger than 1 on a number line. You can get rid of that. You can get rid of that. So last week we did some work with fractions on a number line. This week we're continuing. So we're going to be thinking about, okay, not just fractions on a number line, but fractions that are larger than 1. Thank you, Table 3, for getting that title down in your notebook. Once you have that title, if you would please go ahead and draw a number line. This number line goes 0 to 1. And there is a tick mark that has an R on it. So once you've got that title down, please get the number line down as well. On this number line, we're dealing with a fraction that is smaller than 1. Because our number line ends at 1. Which means whatever the value of R is, it has to be less than 1. Because it's not quite at 1. How would you end bigger than 0? Yeah, how would you figure out the value of R?
0.5.
How would you figure out the value of R? Julian, thanks for raising your hand. What would you do?
Start counting the equal parts of the number line.
I love that. Julian said, I'm going to count the equal parts in the number line up till 1. Right? Yeah. All right. Well, I see one spot right here, and I see another spot right here. Right, Julian?
Yeah.
So I see 2 equal parts. What does that tell me in my fraction? I should see lots of hands because we should definitely know what that tells us. Julian said, I see 2 equal parts. How does that help me with my fraction? Cole?
Half?
It tells me what part of my fraction.
Yeah.
I'm asking. The numerator, denominator?
Denominator.
The denominator. We're counting halves. So I'm going to go ahead and label all the things on my number line with a 2 in the denominator because Cole is exactly right. I'm counting halves. At 0, how many halves do I have?
0.
0. When I make my jump from 0 to letter R, how many halves do I have, Callie?
1/2.
1/2. R is worth 1/2. If I kept going and I did the same jump from R to 1, how many halves have I gone? 2 halves. AKA 1 whole. So far, so good. I think you guys could do that pretty easily.
Yeah.
But I'm going to zoom out a little bit. So think of that frog game on iReady. I'm going to zoom out. And now you're going to draw this number line. It's almost the same one, right? I still have my 0, my R, my 1. But I also have a T over here. So I zoomed out a little bit. Go ahead and redraw this number line.
Just the spots in them.
Sure. Go ahead and redraw this number line, please. I don't need random thoughts said out loud. Now, Julian, am I going to count all the equal parts that I see across my number line?
No.
I am not. This is where a lot of people get tricked. This number line is bigger than 1.
Oh.
Right? Do we see where 1 is?
Yeah.
And we see it
Still
so
half.
yeah. However, when I'm talking in fractions, if I'm talking about 1/3 or 1/2, I really mean 1/2 of 1. 1/3 of 1 or of the whole. 1/4 of the whole. I'm not talking about 1/2 of 50 numbers. I'm only talking about 1/2 of one number. Fractions are only talking about one whole. Write this sentence down, please. Fractions are always relating back to one whole. So if I say half, I'm not talking about half of 800. If I say a half, when we're talking about our fractions, I'm talking about half of one whole. And that's important, because if I know I'm only talking about one whole, then I need to cover up the rest so I can only focus on what's going on in one whole. I'll give you some seconds to write that down and we'll keep going. Alright, so if I'm looking at one whole, that's going to be important because my denominator, what I'm counting by, is not 1, 2, 3, 4. I'm not counting by fourths.
We're counting by halves.
I need to cover up, so I'm only looking at 0 to 1. Put your hand on top of anything past 1. We're only looking 0 to 1. I don't want to look at anything else. Because when I'm forming a fraction, I only care about my fraction in relation to one whole. So Julian, when I do that, how many equal parts do I have? I don't have 3. Look at those equal parts. I have 2 equal parts. I have 1 right here. And I have 1 right here. That's it. If I have 2 equal parts, what am I counting by?
Halves.
Halves. So this is going to be a half. Some part of a half. Some part of a half. Some part of a half. Hey, is this space the same amount as this space?
No. Yes.
So it's still some version of a half. Some version of a half. So let's start counting our jumps. If I'm at 0, Callie, how many halves do I have? If I'm at 0, how many halves do I have? I have 0. What about my jump to R? 1/2. Pause. Is that 1/2 in the middle?
No. Yes. It's in the middle of one whole.
It's kind of a trick question. Lydia, you're correct. It's in the middle of one whole, but is it in the middle of my number line?
No.
No. Does that mean it's not 1/2?
No.
No, it does mean it's 1/2. I just zoomed out a little bit. Right? So we zoomed in and we were first looking at only 0 to 1. Now I'm zooming out a little bit. That's still 1/2 because Lydia said it's 1/2 of one whole. But it's not in the middle because I'm zooming out. What about if I did another half here? What would that be worth?
2 halves.
2 halves,
One whole.
aka one whole. What if I did another hop to T?
3 halves.
3 halves. 3 halves. I can write that as a 1, a big 1, and 1/2, saying I have 1 whole and 1/2. That would work. What if I did another half?
4 halves.
AKA 2 wholes. I'm writing, that means you're writing. All right, we're going to look at another number line. This one's going to have a lot of information on it, and I'm going to have you draw it first. Then we're going to talk about it, okay? So it goes 0 to 3. Go ahead and start your number line 0 to 3. 3 holes, 0 to 3 holes. And in between each hole, I have 1, 2, 3, 4. 4 places. And then I get to 1, 1, 2, 3, 4. And then I get to 2, 1, 2, 3, 4. And then I get to 3. So I'm going to give you some seconds. There should be 12 spaces total. When you're done and you've got it labeled, give me that secret thumb. All right, cool. I know, so I told you, there's 12 spaces from 0 to 3.
Yeah.
Are we counting by 12s?
No.
No.
No. We are not counting by 12s. But there's 12 spaces. Why are we not counting by 12s? That is correct. We are not counting by 12s. But why? Because I counted my places and there's 12 of them. So why are we not counting by 12s? Maverick, why are we not?
Because you have because it matters by like the spaces in between like one hole.
It only matters for one hole. The rest of it just repeats. You gotta make your original one and then you can clone the rest of them. So use your hand and cover up everything until you get to one hole. So most of this is going to be covered up. So only looking at 0 to 1. How many spaces, Connor, are between 0 and 1?
3.
Nope. There are 4 spaces between 0 and 1. If there's 4 spaces in one hole, what am I counting by? Colby? I'm counting by fourths. Label every single tick mark with a fourth.
It's gonna be a lot of 4s.
It is a lot of fourths because every single one of those spaces is worth a fourth. The numerator, there'd be 12 fourths. So yeah, we already know that the end one is 12 fourths. You count all those places. And I bet you know what 0 is.
0, 0.
Hey, just label. What's the first one worth?
1/4. 1/4.
What about the second one?
2/4.
Keep going. You know how to do it.
0, 1, 2. Wow.
Lydia, come right with
What?
my marker. What is A worth on this number line? I have A equals, write the fraction. Try not to put your hand on the board because it's not going to work very well. Lydia says A is worth 3/4. Is she correct?
Yes.
Yes, she is.
There you go.
Paper, you come to B. What is B going to be worth?
Where's the? Oh.
Try not to put your hand on the board because it won't work as well. 6/4. Is she right?
Yes.
Yes. Marley, what do you see? Kind of.
Like skipping mine.
It is this.
Skipping 3.
3 what?
3.
3.
Half.
What are we counting by?
3/4.
Skipping by 3/4.
46. 9.
3/4, 6/4, 5/4. Skipping by
I put mine on C on 10.
Now Marley did it with that slash. Does that still say 9/4?
Yes.
Yes. And you will see that. Most of the time it'll be written like Lydia and Avery did, with a fraction bar just being horizontal, but you will see it diagonal. You see it?
Yeah.
With your best, whatever you like. We got another number line.
Oh wait, no. This is actually. It is one.
We've got less spaces, but it still goes 0 to 3. So go ahead and make your number line 0 to 3, and I'll count the total number of spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9 total spaces. It does go 0 to 3, and there are 9 total spaces. I'll give you some time to get your number line worked out. All right, here's where it gets tricky. We counted 9 spaces. But am I counting by ninth?
No.
No, I am not. I'm not counting by ninth. What am I counting by? This is tricky. Mason, what am I counting by?
So you see D, E, and F's?
I do see D, E, and F, yep.
Between 0 and 1, there is a size of 3.
Love it. Did you hear that, genius?
Yes.
Because Mason knows that when I'm trying to name a fraction, I can only look at a fraction in one whole. Then I'm just repeating over and over and over again.
You're not counting by 9.
So if I cover up and I only look at 0 to 1, Mason told us, hey, there's 3 equal pieces. Which means, Mason, if there's 3 equal pieces, what am I counting by? Your name's not Mason every single time I check. Do you need me to say the question again? If there are 3 equal spaces, what am I counting by? Thirds. Go ahead and label them. You get a third, and you get a third, and you get a third. I don't know. Archer, can you label my third? All of them.
Are you trying to call us?
Try not to put your hand on the board because it gets weird. Alright, we're looking to see if Archer is labeling these correctly. You should be looking at your own number line, making sure you've got yours partitioned. Pause there, Archer. Archer put 3/3, and it's at the exact same spot as 1. Is that a good thing?
Yeah.
Yeah, because we know 3/3 is equivalent to 1 whole. Keep going, Archer. You're killing it.
The numerators are just like counting normally.
The denominator just tells you what you're counting by.
Doesn't that mean that if there's only 9 numbers, or there's only 9 spaces, doesn't that mean you can only go up to 9/3?
On this number line, yes. But do you think the 9/3 is the most amount of thirds you could have?
No.
Alright, is Archer right?
Yeah.
Yes, Archer is right. Emma, give me the value of B. Emma, would you write as D is worth 1/3? D is worth 1/3, is that right?
Yes.
Yes, Emma is right. Paxton, give me the value of E. Paxton was right?
Yes.
5/3, is Paxton right?
Yes.
I want to talk about, there's 2 ways you could have figured this out, so pause your hands for a second. Most of you, I imagine, are probably finding that letter and then looking down and saying, hey, if things are stacked, they are equal. So I imagine most of you are saying E and then looking down and seeing 5/3, so E is worth 5/3. That'll work. You could say, okay, there's E, and then make your hops. That'll work. 1/3, 2/3, 3/3, 4/3, 5/3. Either way will work. Penelope, come get me the value of F. Value of F, please. Alright, Penelope, what'd you write? 8/3. Penelope, right?
Yeah.
If Penelope was at F and she walked one more third, where would she be at now? Okay, great. If she was at 8/3 and she walked forward one more third, Connor, where would she be? 9/3. She would just go one more top. Very good. We've got one more number line. Last one. Ooh, that's a lot of lines. It only goes 0 to 2. It only goes 0 to 2, and I will count them for you so you can get your spaces. Lydia, do you have a question?
Yeah.
Go for
So
it.
if you have a number line, let's say going to like 0 to 3,
Uh-huh.
does it have to be the same amount of spaces in each like section?
Great question. Lydia says, does there have to be the same amount of pieces in between each whole number?
Yes.
Yes. On our number line, yes. Now, sometimes, Lydia, and I'll just give you this quick example. You do not need to write what I'm writing. Sometimes, especially on Freckle Fraction Challenge, I've seen this. They'll go 0 to 2. They'll put one hole. And then they'll put, like, mystery. Now, obviously, are these pieces the same as this piece?
Well,
This piece right here?
but like they're equal.
Exactly. So they might try to trick you, but you have to remember, oh yeah, I can do a ghost piece, and now I have equal size pieces. Does that make sense?
Yeah.
So sometimes you won't see it, but they are there. That makes sense? Yeah. Okay. All right, so I'm going to count the number of pieces because I know that some of that's hard to see. I've got 1, 2, 3, 4, 5, 6, and I'm at one hole. 7, 8, 9, 10, 11, 12. So cut it in half. 12 is an even number. Cut your number line in half. And you've got 6 on one side and 6 on the other side. Paxton, question? What's up? Yeah. It's your notebook. You work what's best for you. All right, we counted, and we said there were 12 spaces. On this number line, does that mean that I am counting by 12?
No, it means that you're counting by 6 because every time that you get to a fourth on spaces,
I love that. Can you say it one more time? Because that was amazing.
like, you don't count by the entire whole every time that you get to the whole.
The entire number line.
You count by the spaces.
So, Art, you said something really interesting, and I think this goes with what Lydia just asked. Art said every hole has, in this case, 6 spaces. Not just the first one. The distance between 1 and 2 has 6 spaces. And I bet if we kept going, the distance between 2 and 3 would have 6 spaces. Exactly. When we're trying to figure out what we're counting by, we're looking at how many places are in a hole. If you really wanted to, could you just look between 1 and 2? That's a hole. You could. Makes it a little trickier, but you could. So, Art, you said that we're counting by what? You're counting by 6. Because there are 6 places in one hole.
That does not make sense to me.
Did you draw all your places? Yes? Oh, there's 6 places in between 0 and 1. I think that it's just, you couldn't see them. That's okay. In a moment, I'm going to give you a worksheet with the number lines so you won't have to draw them. All right, Callie, you think you can label all my 6? If you haven't labeled them, go ahead and start labeling. Pause. Quick check. Callie got to 6, 6. What number should she also be at?
One hole.
One hole. Is she there?
Yeah.
Yes. Then she knows she's in the right spot.
4.
Well, I want you to watch what happens when she gets to 2 holes. Keep going. You got it.
Wow.
You remember we talked about the division problem?
Yeah.
12
6 times
divided by 6.
6 equals. No, 6. No. Wait, what did you say again?
12
divided by 6
12.
equals 2. 12 divided by 6
Divided by 6.
2.
6 divided by 6
Equals 1. Oh, yeah.
just a little bitty division equation.
Oh, remember we did division is fractions?
Division is fractions. I do remember that. I was there.
Second plus 5.
Mason, you think you can give me the value of k?
So hard.
It is a little tricky. That's okay. I'm going to give you some number lines in a second so you won't have to redraw them. All right, Mason, what are you thinking?
4, 6.
4, 6. Is Mason correct?
Yes.
Yeah. Go for it, Marley. Marley, do the value of LP. What you got, Marley?
7, 6.
7, 6. That'll work. Cole, can you do the value of M? And 6. Nice. Raise your hand to tell me which fraction or fractions are larger than 1. Which fraction or fractions are larger than 1? Addison, you got one?
I have 2.
Go for it.
7, 6, and 10, 6.
7, 6 is larger than 1, and 10, 6 is larger than 1. Addison, how do you know that?
I look at the number line. I can look at the number line and see, and I can see that. And I can look above 1, and I can see L is just above 1, and M is right above.
Yeah, Addison says, you know what? I can look at that number line. Go, and I bet you got a trick for figuring out if it's more than 1. Addison said, I'm going to look at the number line, and here's 1 hole. Anything over here is going to be bigger than 1. But can you do another way to tell if a fraction is bigger than 1? Don't do that.
Goes over the numerator, goes over the denominator.
Yeah, Bowen said, hey, if you look at our numerators, they start being larger than our denominators, which means we have more pieces than is worth 1 whole. If I have 6, and I have all 6 of them, then I have 1. But if I have 7 of them, then I have more than what is needed for 1 whole. Does that make sense, Lydia?
I had another way that you could tell if it's
Absolutely.
if you can split the like the whole, well, like all the holes into like 1/2, and then whatever like the numerator and denominator is, that if it goes if it's like 6, if it goes over 6, it would be over 1.
Sure. Absolutely. Absolutely.